Hi, my name is Dhruv Tyagi. In this video, I'll be going over polar derivatives. So to start, let's imagine we have a polar function. We'll call it r, and it's equal to f theta. Okay? So what does this mean? This means that as we change theta, so we have a graph, polar graph. So as we change theta, we get some r values output. So theta here, r values output. So now we want to represent this as an x and a y function because we want to take the derivative, and derivative is dy dx. So let's say, how would we represent this? So we would first say this is theta, right? So this would be r cosine theta, because again, cosine theta equals the adjacent over the hypotenuse. So if I multiply by the hypotenuse, which is r, then I get r cosine theta, or f theta cosine theta. Similarly, I could do this to be r sine theta, or f theta sine theta. So now we know that from this, x is equal to f theta sine theta, or f theta cosine theta, while y is equal to f theta sine theta. Great, so we have those now. Now we need to find dy dx. So dy dx is equal to, if we take the derivative of these two with respect to theta, what we'll get is dy d theta over dx d theta. And the interesting part is, if we divide dy d theta by dx d theta, you can see what happens is that the d thetas cancel out, right? So what we're left is dy dx, which is our original value. So in this case, the process of finding a polar derivative is we find xy, f theta cosine theta, y, f theta sine theta, and then we take the derivative and then just divide them like so. Okay, so let's try it out now. Let's try it out with a problem. Let's say we have the problem r equals 4 cosine theta, and we want to find the derivative or the slope at theta equals pi over 4. So in this case, let's represent this as x and y. So let's start with y first. So let's say y would be equal to 4 cosine theta times sine theta. So 4 cosine theta sine theta. And if you guys know your trig identities, a simple one is that 2 cosine theta sine theta is equal to sine 2 theta. So this part, using trig identities, becomes just 2 sine 2 theta. Okay, now let's take the derivative of 2 sine 2 theta with respect to theta. We get 2 times 2 goes out, so 4 cosine 2 theta. So we could try to find x now, but since we're given theta, let's just see what happens if we plug it in, dy d theta. So we plug it in, we get dy d theta at theta equals pi over 4. We plug it in, we get 4 cosine of 1/2, which is equal to 0. Therefore, the dy dx of this function is equal to 0. And again, we didn't need to do the dx d theta in this case, because we had dy d theta over dx d theta, that's dy dx. And because dy d theta was 0, this whole function had to be 0, no matter what dx d theta was in the bottom. And therefore, the value is 0 in this case. Alright, next. Let's say we had the function r equals 1 plus 2 sine theta, and we're trying to find it at theta equals 0, the slope. In this case, let's represent y first, so y would equal to sine theta plus 2 sine squared theta, and then dy d theta is equal to cosine of theta plus, so chain rule, so 4 sine theta cosine theta, and then dy d theta at theta equals 0, that's equal to, so cosine 0 is 1, sine theta becomes 0, so this whole function part becomes 0, so 1 plus 0, which is 1. Now we do x, so x is equal to cosine of theta plus 2 sine theta cosine theta. Again, trig identity, so this becomes cosine theta plus sine 2 theta. Then we take the derivative. This becomes negative sine theta plus 2 cosine 2 theta. So taking it at theta equals 0, this becomes 0. And then 2 cosine 2 theta, so 2 cosine 0 is equal to 2. And therefore, dy dx at theta equals 0 is equal to dy d theta at theta equals 0 divided by dx d theta at theta equals 0, or 1/2. Again, just to reiterate, the process is we first find y by multiplying the r function by sine theta, find x by multiplying the r function by cosine theta, take the derivatives, and then divide dy d theta by dx d theta, and get our answer. So that's the process for finding polar derivatives. Thank you guys all for watching, and I'll see you guys all tomorrow. Bye.